Hi guys. So in your note packet, we are going to be picking up on page number 5. You are definitely going to want to have a calculator reasonably handy today, and probably your reference tables as well, okay? So the ed puzzle for today is about doing other stoichiometric calculations. Rather than mass to mass, what if we wanted to go mass to liters, or mass to molecules, or molecules to liters, or liters to particles, whatever. So it's the math that we're about to do is not any different than the math we've been doing. The difference is rather than going from grams to moles, moles to moles, moles to grams, we might be just changing what it is we're calculating. So your first step in any of these problems, though, is no matter where you start, you have to get to moles of the given compound. So if you start with volume, like over here on this mole roadmap, your first step would be to divide by 22.4 liters per mole to get to moles of the given. So that's what this G stands for, given, okay? If you start with atoms or particles or molecules, so I guess I'll just call this particles, your first step would be to divide by Avogadro's number, 6.02 times 10 to the 23rd. If you are given mass, like what we've been doing, your first step is to divide by the molar mass of the compound that we're dealing with. So your first step is always going to be dividing, whether it's by 22.4 or 6.02 times 10 to the 23rd or the molar mass of the compound. Your first step is dividing to get to moles. Then you do your mole ratio, which is moles of what you want over moles of what you're given. And you get this from the balanced chemical equation, right? You're pulling the coefficients out of the balanced equation. Your last step then is to convert into whatever it is you're trying to solve for. So if you are asked to solve for volume, you would multiply by 22.4 to get to volume. If you are asked to solve for particles, whether that's atoms or molecules or whatever, you would be multiplying by Avogadro's number to get over here, particles. And if you're asked to solve for grams, you would be multiplying by the molar mass of whatever it is you're trying to solve for, okay? So using this mole roadmap, let's kind of take a look at some practice problems. First thing I'm going to do is draw on my arrows because none of those printed. All right. Number 1 says, consider the following reaction. How many molecules of oxygen are produced when a sample of 29.2 grams of water is decomposed? Okay. So we are given water, H2O. We are solving for oxygen, which is this. So think about what the plan is. We have to get from grams of water to moles of water to moles of oxygen with H2O, molecules of oxygen. Okay. So in order to solve this problem, we need to first go to our mole roadmap. Think about what's happening. We are starting with mass. We are starting here. We then have to divide by the molar mass of water to get moles of water. We're then using the mole ratio to get to moles of oxygen, and then we're going to particles of oxygen. So this is kind of our pathway that we're going to do. Divide by the molar mass of water, use the mole ratio, multiply by 6.02 times 10 to the 23rd. That is the plan, okay? Ooh, that's not what I wanted. Okay. All right, so use my pencil here. We have our 29.2 grams of H2O. Somewhere off to the side, I am going to find the molar mass of H2O. So to do that, I'm going to take inventory. I know I have 2 hydrogens, each with a mass of 1.0 to give me 2.0. I have 1 oxygen, a molar mass of 16.0. Again, taking those masses to the 10th place as always. Add those together. My molar mass for water, H2O, is 18.0 grams per mole. Okay? All right, so that's going to be my first fraction, where I'm going to put the 18.0 grams of H2O in the denominator, 1 mole of H2O in my numerator. So if you set this up correctly, you're going to have grams canceling with grams, all right? My next fraction then is my mole ratio, and I'm pulling this right out of my balanced chemical equation. I know from the balanced chemical equations, there are 2 moles of H2O for every 1 mole of O2. Okay? And then my last fraction here, I have to get 2 molecules, right? So I know 1 mole of anything, so in this case O2, is equal to 6.02 times 10 to the 23 molecules. Let's put that in, okay? So mathematically, what I would do from here is I like to multiply across my numerators first. So if I do that, 29.2 times 6.02 times 10 to the 23, I get, I'm not going to round at this point, that as my numerator, or 1.75784 times 10 to the 25, however your calculator's pumping out that answer. And then I'm going to multiply across my denominators, 18.0 times 2, 36. And then I do my division. So gives me an answer of 4.88. I want to have 3 sig figs, so 4.88 times 10 to the 23rd. And my answer here is molecules. Okay? That would be my answer. Take it through a couple more. Let's skip down to number 3. Consider the following reaction, assuming at STP. All they're saying that for is so you know that 1 mole is equal to 22.4 liters. We can make that assumption though. How many liters of O2 are needed to produce 19.8 liters of SO3 according to, excuse me, the balanced equation, hiccups. Okay, so I'm starting with SO3. They want to know liters of oxygen. They want to know this. All right, so let's set this up. I have 19.8 liters of SO3. I'm going to put that over 1. And then I'm going to multiply that. So then I have my, so if we go back to my mole roadmap, think about what we're doing here. We are starting with volume here. We are going to here. We use the mole ratio to get to moles of wanted to get back to volume here. So that's kind of my path. So I'm dividing by 22.4, using the mole ratio, and then multiplying by 22.4. So you'll see how I handle that in a moment. Just delete that out. Okay. So I know 22.4 liters of SO3 is equivalent to 1 mole SO3. I know then based on the mole ratio, you always put it as moles of what you want over moles of what you're given. So I would have 1 mole O2 in my numerator, 2 moles SO3 in my denominator, and then my last fraction, I'm going back into liters. So I know there's 22.4 liters of O2 for every 1 mole of O2. So with a problem like this, where you have 22.4 liters of one thing in the denominator and 22.4 liters of something else in the numerator, you're allowed to just cancel that out. Like those just go away. Like the whole 22.4 thing cancels. If I cancel out my units then, cancel out just the number here. What I'm left with is liters of O2. So all I'm really doing is taking 19.8 and I'm dividing it by 2. Rounding my final answer to 3 sig figs, I get an answer of 9.90 liters O2 is my answer. Okay. All right. So I'm trying to think if I want to do any. You know what? I'm going to take a look at number 4, but I'm going to change it a little bit. I'm going to change this problem so that it says grams of phosphine. Change it up a bit so we have another example here. So if this question asked how many grams of phosphine are formed when 0.42 liters of hydrogen reacts with phosphorus. So I'm going to draw in my arrow here. And they tell me in this first sentence that phosphorus and hydrogen can be combined to form phosphine, pH 3. So I'm solving for grams of phosphine, pH 3. I know liters of hydrogen. So think about what you have to do to solve this problem. We are starting with liters of hydrogen here. We're going to convert to moles of hydrogen here. We're going to use the mole ratio to get from moles of hydrogen to moles of phosphine. And then once we know moles of phosphine, we are getting to grams of phosphine, which is down here. Okay, so that's kind of our pathway that we're going to follow. So I start with 0.42 liters of H2, my hydrogen. I like to put that over 1 to act as a visual reminder. It's in the numerator. My next step then is to multiply by the fact that there are 22.4 liters of H2 for every 1 mole of H2. So really, mathematically, you're dividing by 22.4 at this step. My next step then is to use the mole ratio. I know based on this that there are 6 moles of H2 for every 4 moles of pH 3. That's the phosphine. You could reduce this down. If you wanted to reduce the ratio, you could. Mathematically, it's all going to work the same. And then my last step is to get to grams of phosphine. So somewhere on the side, I'm going to find the molar mass of pH 3. What do I have? I have 1 phosphorus. Phosphorus has a mass of 31.0. Hydrogen, there are 3 of them, each with a mass of 1.0, which gives me 3.0. Add those together, we wind up with a mass for this thing of 34.0 grams per mole. So move that over here. 1 mole of pH 3, equivalent to 34.0 grams of pH 3. So that is my setup. And if I do this correctly, I should be able to cancel units. Liters of hydrogen, moles of H2, moles of H2, moles of pH 3, moles of pH 3. There you have it. So then I like to personally multiply across my numerators. 0.42 times 4 times 34.0 gives me 57.12. I like to clear out my calculator. Multiply across my numerators. 22.4 times 6 is 134.4. Then do the actual division. I'm going to round my final answer to 2 significant figures because my starting value had 2 significant figures. .43, and that is grams pH. Boom, there you go. So the setup for each of these problems, it's a little bit different for each problem depending on what it is you're actually trying to solve for, right? So you really have to analyze each problem. But it all goes back to using this mole roadmap. You have to get from whatever it is you're starting with to whatever it is you're given. Then you have to use the mole ratio to get to moles of what you want. And then you're converting from moles of what you want into whatever it is you're asked about. Okay. So in class, we will do some practice with all this, but that is the basic idea. The math is the same as what we've been doing. The only difference is now we're talking about like liters and molecules rather than just grams for everything. Okay. So I'll see you in class. As always, guys, let me know if you have any questions.